talking about the importance of machine learning methods in analysis and engineering. We can start with Professor Shafiq.
Okay. Students, so our workshop overview consists of introduction to artificial intelligence, introduction to machine learning and the basics of machine learning, then what is the importance of machine learning in engineering nowadays, and what is the importance of machine learning and the application of machine learning in petroleum engineering, which is your field of study. And then we will discuss some case study examples, okay, how we apply machine learning in different fields of engineering, especially petroleum engineering, and then what are the challenges and limitations in machine learning application, and what are the future opportunities in machine learning, especially in the field of engineering. Next. So what is artificial intelligence? Yes. Have you an idea what is artificial intelligence? You are intelligent guys, right? You are very intelligent students, so you are using your intelligence. Artificial intelligence is something not from your brain, okay? It's like intelligence which can do the work which your brain is doing, but it is not from your brain, it is from it's artificially from machines, right? So what artificial intelligence can do, it can recognize different patterns. It can do decision making by if you give different data, different scenarios to artificial intelligence, it will give you some decisions. Okay, what can be the future predictions? Like if you want to, in field of oil and gas engineering, if you want to predict oil and gas recovery, we will give different data to the artificial intelligence, and we will get the prediction how much oil we are going to produce in future. And automation is also an application of artificial intelligence. So machine learning is a subset of artificial intelligence. Okay, artificial intelligence is a bigger picture, and machine learning is a part of artificial intelligence. And there are different types of machine learnings: supervised machine learning, unsupervised machine learning, and reinforced machine learning. So what is supervised machine learning? In supervised machine learning, you know what type of output you are going to get. Okay, you define the model that this is the output I want to get. For example, in case of oxidizing, you want permeability enhancement. So okay, so we will tell machine learning model that I want increasing permeability, and then you give inputs, and then the machine learning model will give you output in terms of permeability. So this is supervised. What is unsupervised? Unsupervised machine learning, that you do not define the output. You give the data to the machine learning model, and based on the data, machine learning model will give you the output. Okay, it's not defined. Next, why ML matters in engineering? You know, in engineering you have very big data sets of millions of data, right? And it's not easy for someone to process these hundreds or thousands or millions of data sets, okay, manually. So we use machine learning model. Machine learning model, we use algorithms to process that data set and give you the output. And it will identify the hidden patterns within the data. And it can predict the equipment failure, or it can predict the failure if there is chances of uncertainty that your operation is not successful. Okay, so it will tell you about the hidden failures also, and it can optimize your production, it can optimize your processes by giving you the predictions or accurate results, and it will improve the safety and efficiency, because it will tell you that what's going to happen in future, or what will be the prediction, and what will be the results in future, and based on those results you can take care of your health, safety, and efficiency of your procedures. So still going, right? So sources of engineering data. How you get the engineering data? Like you do seismic surveys, right? So what happens when you do seismic surveys? You use sensors, right? And what happens? You use sensors and the tapping material, and the sensors will observe the data, and data is very big, right? So you use sensors and monitoring systems, drilling logs, like you know what is drilling logs? You inject the log and based on different like porosity or density log or waves or sound log, sonic log, right? So we can have a large data set, and that data set is used to find like what is the porosity of your reservoir, what is the type of formation you have. So this data set is basically a big data set, so you can use machine learning to predict your formation. And okay, so I will ask Aruzhan to continue from here.
Thank you. So in order to better understand how the machine learning works, we need to look at its workflow, which consists of 6 different stages. The first stage is data collection. So we can collect the data from 3 different sources. It can be sensors, it can be databases, or it can be experimental data. Then, after we have all the data collected, we can do the data pre-processing. And what is it? Of course, not all data is perfect. So if we have some errors, we need to solve the errors in the data. If we have some missing values in all this data, after processing this data, we can make feature selection. So what does it mean? We have a very large, very big data. So this data is, of course, all this data cannot be used in order to solve problems. We need to indicate some important values. These important values are called features. So after selecting different features or different parameters, we can move to the model training. And what does it mean? Model training usually happens on the historical data. So the larger the historical data, of course, the better the model training will be. So when our data is collected, pre-processed, we have selected features, when we trained our model, of course we cannot start our exploitation of the model, we need to test it. So model validation is the 5th stage in which we need to test, we need to check for its reliability, for its accuracy and precision of the results. And the last step is deployment, which means our model is ready to be used in real life. We can connect it to the sensors and we can start using it to solve different problems based on different conditions. Actually, we have different types of common machine learning algorithms, but we put 6 the most common and the most used in engineering solutions. The first one is a linear regression. Linear regression is known as the simplest form of the machine learning algorithm. So this is actually for prediction. We can predict different values based on the relationship. For example, here you can see the relationship between X and Y, and for example, in petroleum engineering, it can help us to predict the oil rates based on the pressure, or oil rate based on the temperature, etc., etc. Also, machine learning is used in making decisions. For example, in everyday life, we also make decisions. The same thing can be used in the machine learning. For example, if we use this picture, that's the simple example, we can have different conditions. So these conditions are the branches of the tree. For example, the weather can be sunny, it can be cloudy, or it can be rainy. So let's take the weather is sunny. We have the second condition, which is our time. If we have more than 30 minutes, we can take a walk. If we have less than 30 minutes, we can take a bus. So different branches helps us to make the best decision. But what if we have the big data, like the large data source, then we don't need a tree, we need a forest. So this is the random forest, which consists of different trees, which has its own branches, and these branches have own conditions, and based on these conditions, again, we can make the best decision by selecting different trees. We have 4th type of algorithm, which is a support vector machine. So by looking at this picture, we have different experimental data, but without colors, without these vectors, it will be just a mess and will not give any values. But if we divide it into 3 sectors with different colors, with different vectors, we can differentiate blue from red, red from green, and green from blue. So it helps us to identify different conditions for our model. What to do if we have more complex problems? We cannot use these 4 of them. We need to use either neural networks or deep learning. So the last 2 are inspired by the human brain and work the same way as humans make decisions. Of course, we have input parameters, we have our hidden layers, they are all connected, and we have only one single output, which is the best decision made by these connected parameters. Okay, so it's clear that we have different types of algorithms, but how to use these algorithms in petroleum engineering? It can be used in various stages, but we put the main stages such as drilling optimization, reservoir characterization, production forecasting, enhanced oil recovery, and predictive maintenance. So here you can see how the machine learning can be used in drilling optimization. We know that in drilling we have different drilling parameters. It can be weight on bit, it can be a rate of penetration, which is how the drilling bit advances through the formation. It can be, for example, in order to detect the dysfunctions. So by detecting the dysfunctions earlier in advance, we can solve this problem without having this time, which is NPT, which is known as reduced non-productive time. So we don't need to stop the process or the problem, fix and replace. We can know it in advance, and of course we will save a lot of time. It will help us to save the cost of maintenance, and also it's very productive in terms of safety regulations. We can have better safety regulations, and we can avoid some catastrophic events can happen during the drilling. Also, drilling is known as one of the most complex and expensive stages of oil and gas production, so it will help us in these terms. In the reservoir characterization, so what is reservoir characterization? It's simply knowing where the hydrocarbons are distributed across the reservoir, so and how we get these rock and fluid properties, which are, for example, porosity and permeability. Traditionally, there are two ways of getting this information. It can be either in the laboratory from the core data, or it can be from the well logging. So these two methods, let's be honest, they take a lot of time. They have limited precision and accuracy. So what can we do? We can analyze 4 different data at the same time. It can be core data, it can be well logging data, it can be seismic data, it can be well test data, and machine learning helps us to analyze these 4 different types of data at the same time. So it will save us a lot of time, it will give us better precision, accuracy, it will help us to identify the most productive zones in the reservoir. So of course, consequently, it will help us to characterize the reservoir better and identify the most suitable type of recovery for this reservoir. Production forecasting. So traditionally, and also from the production engineering course, we know that we can identify future oil rates, future gas rates by using decline curves. But also, decline curves have this alternative solution, which is the machine learning. By using the machine learning, we can identify the water breakthrough. This is the time in which the water enters the production. So by knowing this time, we can place the well in the most suitable location, so we can avoid lots of problems, we can enhance our recovery, and we can forecast the future performance of gas or oil. Okay, and I would say this is one of the most powerful uses of machine learning in petroleum engineering. This is predictive maintenance, because it helps us to monitor the equipment performance in real life. Actually, for example, in drilling engineering, the most important thing that engineers need to all the time monitor their drilling parameters, and this helps us to monitor them in real life. We can detect abnormal patterns if we have by giving some conditions. We can predict equipment failures, and it helps us to reduce operational downtime. Okay, so in order to understand how the machine learning works in the petroleum engineering, we can just give one example. Let's say in this case study, we want to understand how the pump failure occurs in a specific production. So we know pump helps us to have a flow in the pipelines. So first of all, we can just put the sensors in this pump, and these sensors will give us historical data. Let's say we have 3 input data, which is the pressure, temperature, and flow rate. By having this historical data, we can analyze the patterns that we have in this specific production. By having these patterns, of course, we are able to know the different conditions that affect this production. So we have our data collected, we pre-process this data, we solve all the errors, now we can use it. So by giving the real-time sensors, we can analyze the real-time flow in the pipelines, and of course it will give us the output, which is the time in which this pump will experience the failure. And of course, by knowing this failure time earlier, we can reduce the cost, we can reduce the time, etc., etc. For the engineers, we have different types of machine learning tools. We put just the main ones. For example, Python. It's very useful, it's the most common, it's flexible, and the main advantage is that it supports different various libraries. It can be TensorFlow, it can be PyTorch, etc., etc. Also, MATLAB is one of the most powerful machine learning tools for engineers. because even without having any background in the computer science, as an engineer, you can use the MATLAB because it has already integrated numerical simulation. So this is commonly used among engineers.
Yeah. So now I'd like to talk about the challenges of machine learning implementation. And as we see from the slides here, first one comes as poor data quality. So although machine learning offers significant advantages in engineering applications, its implementation in real industrial environments is not straightforward, as it heavily depends on data quality. So machine learning models rely heavily on these data, and as we know from engineering implementation, sometimes this data is often noisy and sometimes comes distorted and inconsistent. For example, sensors that we use in the oil and gas and production can simply distort under high temperature, high pressure conditions, and that's why this poor data quality can be very dangerous even for the most advanced machine learning implementations. Another major issue is limited labeled data sets. So labeling data sets, it's a very complex task that requires niche knowledge of engineers, and it is very required for the supervised learning. In petroleum engineering, labeling data often requires expert interpretation, which we cannot provide, and that's why identifying reservoir zones or classifying drilling events is very important for the machine learning implementation, which is not done properly in the most cases. Additionally, we also have the problem of model overfitting. What that means? It's the issue of when the model learns patterns specific to the training data, but fails to generalize to new and unseen data that is not, of course, in the training data set. So this is dangerous in engineering applications because it can lead to incorrect predictions in some cases. Finally, we also have the high computational cost. So they require significant computational resources, especially deep learning models, which are most desired, of course, for the real world applications. And this can make the implementation very difficult, particularly in field environments with limited computer infrastructure, which is often the case worldwide. Okay. Now let's talk about integration challenges. So first of all, beyond technical challenges, one of the biggest barriers to adopting ML in engineering is the difficulty of integrating it into existing workflows in the current oil and gas production. So many engineering systems, especially in the oil and gas industry, rely on legacy infrastructure that was developed decades ago, if not centuries ago. So these systems were not designed to handle large-scale data that we would like to use the current advanced ML implementations, and they cannot handle them or process them. So as a result, integrating ML solutions often requires upgrading data pipelines, which is again very expensive and very costly. And sometimes we need to redesign the entire workflow, which is again very difficult. And that brings us to the next problem, which is the lack of ML expertise. So successful implementation of ML requires knowledge of both engineering principles and data science, which most professionals do not have. Mostly the professionals are either engineers or data scientists, but we rarely see professionals with expertise in both. So engineers may not be familiar with machine learning algorithms, while data scientists may not fully understand the engineering principles or the workflow and physical systems and constraints. So this gap creates communication challenges and of course slows down implementation. And it brings us to the last problem, which is the organizational resistance to new technologies. So as we know, there is often a very big resistance to adopting new technologies, especially ML. Mostly managers are hesitant to trust machine learning models because they have never been used before. They have issues with trusting it completely, which is also of course reasonable. And especially when decisions involve high risk operations such as drilling or reservoir management, which of course mistakes in those areas cost a lot of money. To overcome these challenges, companies need to invest in training, promote collaboration between engineers and data scientists, and gradually integrate machine learning into decision-making process. All right, and of course, when we talk about machine learning, we also have to consider ethical considerations, starting with the most important one, which is data privacy. One of the primary concerns, and engineering data may include sensitive operational information, and it is important to ensure that this data stays safe and confidential, and it is also used securely. Unauthorized access to this data of the companies could lead to serious consequences, including financial loss or even safety risks. Next up, we have model transparency. So most of the time, many advanced machine learning models are considered as black boxes because it is difficult to understand how they arrive at their decisions or results, which is really not good. In engineering applications, this lack of transparency can be problematic, as engineers have a need to see through the decision-making process to ensure that the decision was made correctly and safe, and it's not harmful to the operational costs. Next up, of course, we have reliability of predictions, which is the most important part of machine learning implementations overall, because they are not perfect and can make errors, especially when exposed to new conditions that were not present in the training data, which is often the case. So in high-risk industries such as oil and gas, mistakes like this and incorrect predictions can lead to safety hazards or operational failures. And we need to talk about the responsible use of artificial intelligence. Engineers must ensure the responsible use of AI, meaning that machine learning should support human decision-making rather than replace it entirely. Human oversight is definitely needed, and it's essential to ensure that decisions remain safe in the physical constraints and aligned with engineering standards. Now let's talk about the future of machine learning in engineering. So we have several examples of how we can use ML and implement it in the future. First is starting with digital oil fields. So one of the most important concepts, digital oil field, is where all the operational data from sensors, equipment, and reservoirs is integrated into a centralized digital platform. So this digital oil field and machine learning models can analyze this data in real time, allowing engineers to monitor and optimize operations continuously and try to make some experiments that are not affordable in the real oil field, of course. Another key development is real-time predictive analytics, where machine learning models process incoming data instantly and provide recommendations for the operator. This enables faster decision-making and reduces response times and, of course, human errors. Autonomous drilling systems is another invention that might be possible in the future. There, machine learning algorithms can automatically adjust drilling parameters based on real-time conditions. For example, as you know that most modern engineers constantly operate and see the mud weight balance, and it needs to be constantly changed, adjusted, either lowered or increased. So instead of having human error risk, we can create an autonomous drilling system for that. And of course, we come to the smart reservoir management, where machine learning can predict reservoir behavior, optimize production strategies, and improve recovery rates at the real time. All right, now I would like to talk about one example of how ML could be used in gas lift optimization, for example. So advanced application of ML in petroleum engineering is in gas lift optimization, which is widely used in artificial lift systems. So in traditional gas lift operations, which are used nowadays, engineers manually adjust gas injection rates based on periodic measurements and experience. However, this approach is often inefficient because reservoir conditions change constantly, and again, there is a high risk of human errors and calculation mistakes. With machine learning, we can develop an intelligent system that monitors real-time data such as pressure, temperature, and production rates. The ML model can detect inefficiencies such as pressure drops or unstable flow conditions and determine the optimal gas injection at the current moment, which is needed for the, again, optimal production. In addition, AI can be used to control chemical injection. For example, which kind of chemicals should be injected, or what amounts, what injection rates, to reduce scaling or corrosion, which is a big problem nowadays also. This approach not only improves production efficiency, but also reduces operational costs and minimizes human intervention. To conclude, machine learning is rapidly transforming the way engineering problems are approached and solved. By leveraging large volumes of data, machine learning allows engineers to gain deeper insights into system behavior, improve operational efficiency, and reduce risks. In petroleum engineering, ML is not implemented heavily nowadays, but machine learning has already demonstrated its value in optimizing drilling operations, improving reservoir characterization, and optimizing production forecasting. As technology continues to advance, the integration of ML into engineering workflows will become increasingly important, and engineers who embrace these technologies and concepts and develop necessary skills will be better prepared to address these challenges of the modern energy industry. Ultimately, machine learning should be viewed not as a replacement for traditional engineering methods, but as a powerful tool for engineers to complement and increase the oil and gas production. Thank you very much for your attention. We hope this workshop has provided you with a clear understanding of how ML can be implemented, and we will be happy for any questions.
I have a question for Medet. Do you have any personal experience using ML for such petroleum engineering problems as you mentioned?
I think yes. So there was one problem I tried to tackle. It was I think related to hydrate formation in the pipelines, in the surface pipelines, and I tried to use ML to categorize the formation of hydrate. So the risk, what's the risk of formation, and what's the possible location of the formation based on the time, on the pressure, and the temperature, and all the other input information. Oh, yeah.
Thank you.
Thank you, students. Okay, thank you.
Thank you.